Okay, thank you very much. We're gonna get going on the next session. The title is International Data Security and Consequences for Implementation. This is the most popular topic that everybody requested. I just want to see if anybody's awake. It's good. So we'll get going. I'm Jim Mulshine. I'm still a thoracic medical oncologist.
Yeah, I'm Tony Reeves, and I'm still engineer from Cornell.
Okay.
Sorry. And would the panelists introduce themselves?
Hi, Rick Avila. I'm head of Acumetra.
Mary Ellen Geiger, Department of Radiology, University of Chicago. I do development of AI in medical imaging and metric.
David Clunie. I used to be a radiologist, but now I just do DICOM.
André Rossem. I'm not from the Amsterdam University Medical. I like the promotion, but I'm from the Nelson Plus company. And I'm experienced in implementing data management and workflow solutions, like I explained yesterday also.
Yeah, and let me just say by way of introduction, we've talked about the importance of cooperation, collaboration. We talked about the importance of AI, but in order to make these things happen, potentially collaboration, standardization, harmonization could help us all a lot, because every step of this involves a certain amount of processes. If people have worked out these processes, I don't think we have to discover unique solutions to every aspect of this. And this is one area where I think a lot has gone on. We fortunately have a very, very engaged group of investigators on our panel to talk through some of the issues about what's available and how we could avail ourselves to it to allow our dreams to be realized in a more swift fashion.
So I'll just speak from where I sit, so it's not too crowded up there. I'll try and keep this brief. I tend to have too many slides and I tend to talk too fast, so slow me down if I get carried away. Yeah.
Oh.
So as I mentioned, I'm into DICOM. I'm the editor of the DICOM standard, have been for some 25 years or so. And I still do better work in cancer with the NCI on various contracts, and I consult occasionally. So what are we talking about here? Data has been mentioned many times during this meeting. And so today we're going to focus on how that data gets to where it needs to be and how we make sure that its confidentiality and integrity is preserved in the process. And by data in this context, we're talking about not just the pixel data that the algorithms use to find nodules, for example, but also the metadata that accompanies it that's necessary to assure that those models are properly generalized, to route the data to the correct algorithm, to identify the correct patient, and all sorts of other stuff. So we've got the image data, we've got metadata that may be structured, that may be unstructured, and we also have annotations that are used not only for training, but also for communication to the radiologist and the referring physician, and for various other purposes. And so I'm going to focus on three kind of aspects of this. There's a so-called CIA triad: confidentiality, integrity, and availability, which is a common phraseology used in security realm. I'll mention FAIR, the findable, accessible, interoperable, and reusable. We've talked a lot about algorithms that are used in research, algorithms that are used clinically, but we also need to address the matter of how reproducible are they? The vendor may claim that it does something. The academic who publishes the paper may claim it does something. But as we know, 95% of science as published in the literature is not reproducible. So we need to address the reproducibility concern. And availability and accessibility implicitly implies the need for a standard format and protocols to communicate, and that's largely DICOM. So you'll see pictures like this scattered around the internet and the security literature that talk about confidentiality and integrity, as well as availability. I'm not going to dwell too much on availability today, but focus on the confidentiality and integrity components. Availability, I'll just jump into the findable, accessible, interoperable, and reusable category. I'm sure you're all intimately familiar with this, most of you being academics. And DICOM is the one true way to communicate, of course. So what does confidentiality mean in different contexts? So for active clinical data, we all know that patient records have to be protected. But at the same time, that data needs to be identifiable. It needs to be protected from access beyond the clinical team. And when data is then used operationally beyond the scope of the clinical team, such as by a third-party AI provider, steps need to be taken, which range from various different encryption mechanisms through transiently de-identifying it and then re-identifying the results when they're inbound and so on and so forth. But this is a increasingly critical area that we need to address specifically in lung cancer screening context, because a lot of the analysis will be performed off-site by third parties. And then for research, other than for a clinical trial where the outcome of the research affects the patient's immediate management, for example, are you testing an algorithm or segmentation or something like that? Whether it be internally or externally, whether it be commercially or academic, the data usually needs to be permanently de-identified or anonymized, the terminology depending upon your jurisdiction. And as I mentioned, there is encryption as a solution, both in transit on the network, as well as at rest on physical media and in the cloud, and various approaches to the de-identification problem. Then on the other side of the coin, we have integrity. We need to make sure that in the appropriate context, we have enough information to get the job done, that information is correct, that it hasn't been manipulated in some circumstances. We have to be concerned about that. But that mostly our concern is that it's sufficient. So as you've seen from some of Mary Ellen's slides in this meeting, study description is a very difficult thing to nail down, even though we're all dealing with a non-contrast chest CT. How hard can that actually be to be described well? The answer is very hard in an operational context. And this needs to be communicated to the downstream algorithms. The algorithms need to know a lot of detail about the reconstruction kernel, for example, which has been a topic of conversation here. And this applies to research as well. So when you are planning on de-identifying data for a particular application, you need to do so with preserving the necessary integrity, preserving the research utility in a training context and the operational utility in an operational context. You can't just throw away all the private data elements, for example, because they may contain that one critical piece of information about the reconstruction algorithm that's necessary to make the nodule detection algorithm actually work. There's a couple of overall security considerations, some of which we might want to touch on today, or some of which may just be out of scope. But always remember that anything to do with security is an organizational problem, not a technical problem. It's mostly a people problem. Most attacks are by insiders, and not necessarily malicious insiders. They may just be incompetent, and that incompetence is not their fault. It's a result of poor training, poor procedures, poor documentation, and so on and so forth. So security is a big problem. There's also the question of actual versus perceived harm. People will tell you that it's a bad thing to leak patient data, but is there actual harm caused by it? With what information is it associated, and what actual harm occurs? So there's a spectrum of harm, just as there's a spectrum of risk. Increasingly, there's talk of zero trust as networks expand, which means that you treat the people inside the same way you treat the people outside. And when you are doing remote access, this obviously makes sense. Organizations are complex. Complexity equals vulnerability. New is not necessarily better. Just because somebody comes up with some funky new technique that seems to be a panacea, beware. There are very few revolutionary improvements in security-related topics, as far as I'm aware. And the other thing is, the agenda mentioned this, healthcare is not banking. So don't oversimplify the analogy. Healthcare is specific, healthcare is complex, lung cancer screening has its own specificities, so be aware of overgeneralizing. On the subject of de-identification, which is one of the topics that presumably we have to talk about in this context, there are tremendous variations between the different jurisdictions. Europe and the United States and Asia, even Scandinavia as part of Europe, have completely different views of some aspects of this. And it also varies over time. Our tolerance for risk may change, the threats may change. It's very important to define both your tolerance and your threat model. What are you trying to protect? How much protection does it really need? Who establishes that threshold for risk? Do you approach this in an emotional way or in a quantitative way? And there are two basic approaches to de-identification. One is a so-called rule-based approach, which you'll be familiar with, like the HIPAA 18 elements rule, which says you've got to remove X, Y, and Z, but it's okay to leave other stuff. And then they're statistically determined, how much do you need to know about the patient to narrow down the group that they can be re-identified as being part of? Given enough information about race, sex, gender, diagnosis, and so on, it's very likely you can significantly narrow the pool against which to match. We were tasked by the NCI to create a task group, which exhaustively investigated a whole bunch of aspects of this, both in a traditional DICOM radiology sense, but also for other image-related topics, for example, whole slide imaging, histopathology images. And so we wrote a report, which is too long, I'll have to be honest. But if you're interested in a sort of state-of-the-art snapshot of what problems we face when doing de-identification, this report may be useful to you. The best practice number one that we came up with was basically de-identify everything, including all associated data sets. People obsess about de-identifying DICOM images, and yet then they send an Excel spreadsheet that has not been even considered from a de-identification perspective as clinical metadata or outcomes metadata. You have to consider the whole lot together, in addition to how it might be associated with other publicly available information about the subjects who have been nominally de-identified. We were looking at this from a public data set release perspective, which is the most burdensome from a de-identification perspective, but the same also applies to perhaps lesser extent to sequestered data set. Also consider that the identification leakage may occur in the pixel data or in overlays or in annotations that have been made about the images. There are all sorts of sources that need to be considered. Don't forget the statistical approach to disclosure control. You may need to bin ages more than you might have considered. You may need to remove gender. And the converse of this, of course, is that nowadays with AI, we can recover the race, gender, and age plus or minus 5 years or so from the image itself. So you may go to great lengths to remove this from the metadata, but you just get it back from looking at the image. There are limits to what we can do here. Finally, you can release data publicly. I know not everybody in the room is a huge fan of public data release or completely publicly releasing data, but here, for example, on the Image Data Commons project, which I'm part of, full disclosure, we have, for example, the entire CT collection from NLST, such as we are aware of it, as well as the histopathology data, and this is now available for anybody, anywhere, without any request to compute on in the cloud, which hopefully will help advance the state of the art. The other thing I wanted to point out is on the left, you can see that there are secondary analysis results already included in this collection for sharing. These have been produced by people who had nothing to do with NLST, who don't care about lung cancer screening, and just wanted to segment the whole body because it was a cool data set. And this is what public sharing allows, secondary unanticipated reuse that brings benefit back to the original purpose eventually. Additional concerns in the AI world, and this is my last slide, I'm going on too long, I know. A lot of these are self-apparent, but the AI, if it has done nothing else, it has increased demand for data, but it has also changed the value attached to data, which has its pros and cons from a confidentiality and integrity perspective. We need to consider the fact that models are data too. Because the models are built from data, some of the identifying information in those models may also leak through the data. So just bear that in mind. And further, that with the great enthusiasm for federated learning, there is a greater risk of having in-house code. You're bringing in more code from outsiders, which may or may not be well screened, and your IT people don't have a snowball's chance in hell of being able to evaluate it to the degree necessary. So you're going to require expertise to be able to tolerate this kind of ingress into your internal organization. Some of this risk can be outsourced by using AI in the cloud, and the third-party providers will take on some of that risk for you, of course, at a cost. This brings up the question of provider auditing. Those of you who follow the security literature may be aware that most breaches these days of a technical nature occur through the exploitation of flaws in third-party libraries. So the more you outsource, the more dependencies you have, the more risk you have, and the due diligence that's required involves auditing the provider's security penetration tests and all that kind of stuff. Needs to be extended to imaging, AI, research, de-identification tool, and so on. Finally, since de-identification is the thing I'm most into these days, AI as a de-identification tool needs to be considered. It provides a great opportunity, but it also provides a threat because it also makes for great re-identification tools. So as we know, facial recognition has become routine. I was distressed when I got on my United Airlines flight to get here. They didn't even bother looking at my passport or my boarding pass. They just looked at my face. And that's now the state of the art. We shall see how this all works out in the end.
Thank you, Dave.
So I just, on this topic, our usual 2 to 3 slides on this from the MIDRIC perspective. And I talked about this yesterday, so you know all about this, but I just want to let you know that, so MIDRIC is a diverse, curated, scalable, and open data set that enables diverse data and diverse AI developers to develop AI. So we talked about how 80% of it is open. The rest is sequestered for evaluations to go to regulatory. And similar to David, we have fair data in a safe environment. And this is through, because we sit on the Gen 3 platform. We right now are centralized, but we will be also federated. So doing things like containerization is simple, but to do it within a secure environment is difficult. And that's so the MIDRIC is protected as well as the person who is putting their system in a containerized system. We are moving to index. You know, we're talking about how do we handle security of looking at multiple data sets. And one way is to index other data sets to first find out what's out there. And then based on there, then work through the security of how to use that in one's AI development. The other way is to extend where data sets are in a distributed way using Edge Node, where we can then index and potentially use information from, say, local hospitals who are willing to work within this environment for federated learning. And then once you need to gather the data, the interoperability among it. I want to point out that this stuff is technically possible. What it comes down to is governance and people who decide on the governance of these different pots of data. So just want to point that out. And I think I had, right. And I have this up here because with the security, it's important that developers have access to different data sets and also data sets are accessed by different developers. This is a slide here where on one axis is the probability, these are all patients. One axis is the probability of cancer from, let's say, AI system B, and the other one is from AI system A. And you see that in a perfect world, all the greens would be at 0, 0, and all the reds would be at 1, 1. 100% likely to be cancer. But you see with these AI systems, they're pretty much correlated. Say they're all doing around 80% accuracy. I don't like that word, but we use it here. But you're seeing sometimes one system gets it right and one gets it wrong. And many AI systems will be but one single black box with multiple algorithms. But I think what this is showing is these algorithms come to be by diverse developers using diverse data. And so the security has to go both ways here and that's what we're going to be talking about now, how to do that. So I just want to end with this slide. This is how MIDRIC is being set up. It has the central imaging hub, but it operates with other data commons. For example, the NCI Imaging Data Commons interacts with other institutions like Stanford, and ultimately will interact with hospitals. But what's important is that all this is done in a secure way. And we sit on Gen 3, which has progressed over the ages, where we went from commons to meshes, and now we're on Fabric, where we can scale up everything in a secure area for both data and computing infrastructure. So it just gets more and more complicated. So that's all.
Thank you, Ariane. Could you perhaps comment on what is the functionality that, say, a group would come and say we want to share data and people come to you, say, we'd like to access the data. And the sharers, do they declare what they have to share, and do they put constraints on it? Is that the general treatment?
Right. So basically, when we find, and people have, more and more institutions are willing to share, and we have data from all over the US. We have a list of minimal images and a minimal metadata, because the goal is to interoperate in the cloud to get other data out there. So they come in, we have set means of de-identification. Even if they de-identify, we will go over to make sure it's done right. We also need to then go over and make sure, as David noted, you don't want to de-identify by wiping out the whole DICOM header, because you lose all the acquisition information. You want to just de-identify what's necessary. I think it's really important that the people donating know the process where our data is going to be de-identified and what is the curation process. So there's a lot of SOPs done within Midrick that are then public, so people will know. The donor needs of the data needs to feel secure, that their data is going for the common good without compromising their patients.
Mhm.
And we like to tell people the patient benefited from the data because it helped in their medical care. The institution benefited because they were paid for that exam. Now we should have a second use of it so that others can benefit. I don't know if that answered your question.
Before we get into the panel discussion, Dr. Van Rossem, is there anything you would add from the experience of Nelson that's turned out to be, particularly useful, or any best practices that you would like to recommend?
Yeah, for sure. So I heard some good news. So anonymization and securing data, etc. But that's really contradictory in integrating the healthcare systems all together. So, and that's what I normally see in implementing like a solution like we do, like a data management solution, which needs to interact with a lot of stakeholders, with GPs, hospital information systems, etc. And we always have the burden about the data security officers, which gives you like a pile of papers which you need to fill in. But on the other hand, you fill in everything and then that's it. Then you are secure, so to say. So it's like a paper security, what I always call it. So yeah, based on that, I think, but maybe too later to discuss, is I think we need to more audit like what we say on paper. That's what I see in my work, so to say. So we implement a solution, we sign a paper, and that's it. And we will never be audited after that again. And I think that's the biggest risk in my work field.
Could I ask a general question here on the model? Is that contributors submit data, and then users extract the image data, download it, and use it. Is this the most important mechanism, framework for this repository, or is sort of sequestered access something, or are there other features? I don't know if you've had experience with these with anyone on like the panel like to comment on that. Is that?
Go ahead. I'm not sure of the question. So
Oh, okay. Well, when you said the sequestered use of data, that's one of my picky words. For sequestered is a data set that nobody touches, that it's put on the side. For Midrick, it's 20%. No one touches that. So people can take the open and train and validate, but when it comes to the testing for, say, going to regulatory, we will test for them, and that's why it's sequestered. So it's just, that's how you sequestered. You asked, do, people donate and then people download? I think in the future, and that's where this fabric, this ARPA-H, the fabric, which will think of I think I understand it better if I think simply that ultimately, we download data from all over the place and we all analyze it with the computers in our laboratory, but that's not that good. And in the future, where things are moving is, and we have that now in Midrick through the BRH, we have a secure enclave. And so if you want permission to use this data set and metadata from here and here, you need to get credentials on all, say, 3 of those data sets. You need to sit within the enclave, and then you can do all the processing you want. And that's, I think, where the future is going. And that will eliminate some of the concerns on the privacy and security part. And these 3 data sets will then be linked through some honest broker that's also in the fabric that people don't have access to. So that when I have chest X-ray 1, 2, 3 here, I know that I can get the corresponding data. So I, as an AI investigator, can do my research over this multimodal data set. So I think that's where it's moving, where people won't really download, but will navigate through large centralized data sets with distributed smaller data sets in there.
Just one final detail on that. The access to the sequestered data, what is the mechanism by which a user would say, here's my AI, please run it for
Okay.
me, return the results? Is that?
Thank you for that question. Basically, this is 20% by patient sequestered data, which has matched demographics to that in the open, but different patients. The company or the investigator would come to us, and then their algorithm would have to be containerized and put into our secure container area in Midrick based on their clinical question, clinical claim, intended population. We would then draw from our sequestered data set that distribution. Maybe they need to be tested on 100 cases. We would put out those 100 cases. We would run it for them, and we would say, oh, you got a 0.93 under the AUC. We won't give them any other information because we don't want them to train to the test. And in fact, we're doing studies on how often could a company come back to the well. Say they come back next year. They say, we've improved. We want to be tested again. We have to again draw from our sequestered data set. So we're doing evaluations on how often could a company come back based on how much of their type of images we have sequestered, so they don't learn to train to the test.
And they just get a single number for such from.
Right.
it. Yeah.
We're in development of this working with FDA so that FDA would get a lot more information because they actually want to go through approval. But
If I can comment on that, I think a lot needs to be learned from the history of challenges. So, since the AI movement started, there've been a lot of challenges hosted, for dermatology, ophthalmology, all sorts of different medically related as well as non-medically related activities. And they obviously have a quote sequestered data set that they use to establish the leaderboard towards the end of the study. But as we've seen from almost all the challenges, they begin with material that they release to you with the truth so that you can train. And then there are additional phases of the challenge. Ultimately, there's a test at the end and you don't have the answer clearly. But after the challenge is completed, the data is released and they move on. Frequently, the data is released and then they move on and get more data. So I think one of the things we can learn from them, apart from the infrastructure that we can reuse, is the fact that you need to continually acquire more data, whether it be data intended to be shared publicly, data intended to be trained upon. And yesterday's testing data will become tomorrow's training data because you'll have new testing data. And it's not like people aren't going to keep getting lung cancer and aren't going to keep getting scans. So you have to have a provision that allows you to continuously acquire more data. The other thing I didn't touch on my presentation, which may or may not be relevant to you guys, is the need to continuously monitor the performance of an algorithm in the field. What, the drug people would call post-marketing surveillance. I don't know if CDRH uses the same terminology, but if you have an AI algorithm deployed, and we learned this from the MAM-ILCAP experience, nobody was monitoring its behavior. And that was unfortunate because if it were monitored, changes might have occurred earlier. And so if you deploy an AI algorithm today, and we've heard just this very afternoon about the fact that their performance varies over time. This morning, we heard that the recon kernels or the reconstruction algorithm changes on the same scanner. It's called the same thing, but it doesn't behave the way it behaved yesterday. That will have a downstream impact. Nobody will notice unless somebody is paying attention until there's a very bad outcome or an extreme change in behavior that even the humans notice immediately in clinical practice, assuming they're paying attention. So you need an automated monitoring solution, which in turn is a source of data. So if you can monitor it, you can capture it, you can share it if you're willing to. So I think that trying to leverage the post-marketing surveillance infrastructure deployment, which is nascent if even exists anywhere right now, to capture more data for ongoing acquisition, both for training and for testing data sets, sequestered or public, will be the answer in the long term.
And I totally agree with that. You have to keep increasing the data sets. So with Midrix, we keep increasing the data sets. Our 80% increases and our 20% sequestered constantly increases, because or else you're going to train to the test and you don't want that. But we never release it.
Okay, thank you. So we've got a very clear perspective now of on Marvel there. Maybe I can get comments from the whole panel, starting with you, Rick, and let's see what are we fitting that need, or are there other aspects we should be considering in this, especially in this context?
Well, I just want to give you a perspective. I've had the pleasure of setting up like 3 or 4 large databases. One of them was the QIDW. You may be familiar with it through through Kiba, RSNA Kiba. I was director of medical at Kitware at the time, and then prior to that, actually, we developed something called GiveAScan, and Sheila's probably here somewhere. Oh, there you go. And that the idea there, which I think is worth mentioning, was let's give patients a chance to donate their data. And I've actually always said we should really allow people globally to opt in to make their, let's say, imaging data of a certain, let's say, de-identification level available to the world. Now, a lot of people donate their organs. I'm one of them, or maybe one day. But I've agreed. It's a good thing to do. So my point here is that I just keep seeing the requirements on security just keep increasing, and the IRBs keep asking for more and more. And the amount that it slows down research just doesn't seem to be part of the equation. It's like you just got to live with it. So it would be great if the community could come together and agree on a way that the world could opt in to donating their data in a reasonable way. Imagine we took the space of lung cancer screening and we said every person who gets lung cancer screened would also be asked if they would like to donate their data in a broader way. And I'm not familiar with all the legal issues associated with that, but I'm just saying that we have to the community needs to find a way to deal with this through a population of the willing to donate data. Secondly, I had the pleasure of working with IASLC, Karen Kelly's here, on I-ELCAP, the Early Lung Imaging Confederation. We just published a paper in January where we provided data from 7 institutions around the world, 100 data sets, 2 time points, 25% were cancers. And of course, it had to all be de-identified. And we leveraged a person who was on your paper, John Perry, right? And he's kind of one of the go-to people around the world for de-identifying data. And he used international standards. There are international standards, right, that have been developed around levels of let's say, de-identification. And all of that de-identifier is open source and available to the world. And so what I'm trying to get at here is that as we try and deal with all of these requirements around security, there's an open source set of solutions being developed or continuously being refined that will help do that in a less labor intensive way. So I'm hopeful that between the community, let's say, making more data available to the world, and the open source community making more tools available, we'll get some balance here, because right now it's really lopsided.
Sure. As I said, we work NCI, CBIT, they're the guys who pay for Imaging Data Commons, also have an initiative called a MIDI, a Medical Imaging De-Identification Initiative, which consists of a number of different aspects, one of which was a task group that was convened to look at what we need to do from a technical perspective to share data publicly, because that's what we do. And that worked out quite well. We convened experts forever, including John Perry, who's the author of CTP, the clinical trial processor that was originally developed by RSNA for the purpose of teaching files, believe it or not, because radiologists, for some reason or other, like to hoard pretty pictures that illustrate a problem, whether it be for their teaching purposes or for just because they like collecting stuff. And so teaching file creation is a very big problem in radiology, particularly with PACS and digital and all that kind of stuff. So RSNA paid to develop CTP, which has grown into this very robust tool for creating a pipeline to de-identify data on a large scale in a scripted manner that allows you to tailor it to your individual trial or whatever your purpose is. And default configurations are available to comply with various different standards like DICOM Part 15, which specifies what you need to remove under certain circumstances. So there's a lot of discipline, there's a lot of tooling, but it doesn't detract from the fact that it's very difficult to quantify what your residual re-identification risk is with images. Pragmatic experience would suggest that, TCAIA, the Cancer Image Archive, has been sharing data for decades now, publicly on very large scale, and there have been no successful re-identification attempts on that data by external parties. So there's anecdotal evidence for what that's worth that you can de-identify successfully, and TCIA is a combination of using CTP, using their own internal tools, using well-documented human curation processes. It's a very tedious process that's difficult to automate. And I mention that because in the context of the NCI MIDI initiative, we're trying to use tools that allow us to de-identify things with minimal human oversight. So without having to have a human look at every plain text string in study description, for example. And so we've been leveraging cloud-based tools provided by some of the major cloud providers in their healthcare products that not only de-identify the DICOM headers, but also look for plain text descriptions, look for burned in text in the image, like on a chest x-ray, you may have the patient's name burned in, for example, or on a photograph, you may have the patient's name somehow present, or other forms of identifying information. And we are not yet at the point where we can trust the algorithms, whether they be AI-based or heuristically rule-based, regular expressions, that kind of stuff, where they can operate unsupervised. But we may be at the point where they can operate with a sort of quality control paradigm, where risky subsets are sampled and reviewed by humans, the rest just goes through. Sort of like your lung cancer screening program. One day you want to move towards not having humans look at the ones that are negative, or whatever. The same is true with de-identification. And once it can be automated and provided on a large scale, then the risk can be reported as being lower to the institutions that have to pay for de-identification to share their data. So it's all very well to say people should share their data, but there's a cost to data sharing. Somebody has to set up the infrastructure, somebody has to staff the infrastructure, somebody has to perform the de-identification, QC the de-identification, and then the receivers then probably go through exactly the same process because they don't trust the senders. So we need a more robust infrastructure that can be fully automated to de-identify everything on a routine basis, because most healthcare data, images or not, is completely wasted after it's used for the immediate clinical decision-making. The vast majority of data is never reused, except for nefarious business purposes, but that's a different story.
Andre, you can comment on
yeah, I can
experience.
comment. Well, I was never involved in setting up large data sets on the cloud or whatever. But what I do agree is about the costing component, and of course the agreement you need to have in place before you can share data between two parties. And that's always the biggest issue. So even if you go international, so to say, you have all kind of different regulations. You have the HIPAA or GDPR or whatever. And that's the biggest hurdle what I see from my work field. To have an agreement And then comes, okay, the costing and setting up the technical infrastructure for that.
Maybe I could ask you a question then. Obviously, sharing data is critical to AI development and to both products and serving the community. Yet there's going to be immense resistance, and from the states I can think of legal complaints from institutions about exposing themselves by sharing data. Do you feel we have the necessary tools? Are they well formulated to dealing with securely with patient data and anonymizing and managing to get, or and are there multiple choices to pick from, or is something missing, or more than one thing missing from that?
Well, I don't think there's a lack of institutional will. I don't think there's a lack of legal tolerance for it. I mean, demonstrably, probably everybody in this room has been involved in some data sharing project. Nowadays, you can't get funded to do any kind of research if it's government funded without a commitment to share your data. And that data ultimately comes from patients in institutions who are used to sharing data. They share it with pharmaceutical companies all the time because they're paid to do it. So there's a whole industry set up to handle this, and the institutions and their IRBs and their business decision makers, and their risk management and legal decision makers are all fully aware of the issues. It's really more a question of incentives and cost, in my opinion. You just have to change the incentive model, reduce the costs such that it becomes feasible to do it on a larger scale. And, to be honest, some of the worst offenders in restricting data access are the academics responsible for the trials that collect the data. It's nothing to do with the lawyers. Easy to blame the lawyers, but if the academics won't release the data until they publish the crap out of it and it's 10 years old by the time it comes out, then, what use is it? But I don't want to get on that hobby horse.
So to follow up on that, is there some collective activity now that our community should be doing to enable to facilitate the creation of data sets that are going to benefit, for lung cancer screening and related diseases? How do we go forward from here? I mean,
There is a model. There's a program from NIH called All of Us. They're collecting data on 1 million people, and you can sign up at your hospital for it, where all your exams go that route. And so it's similar to what Rick had said about patients. Patients are donating. And I think that's great because we run into some institutions that it's zero. They will not donate. And then other institutions, they will. And I always ask, well, what if a person at that institution says they want their data to go? There's going to be that conflict, and maybe that will push it out. We have a couple of places like that don't want to give to MIDRC. We're happy to use MIDRC, but not give it. But I think if we go the person route, then that, and so maybe fashion it after All of Us.
is that a service that?
It's an NIH program from, I think it's under I-ELCAP Institute. It's just called All of Us.
Now, would that work internationally?
Well, I don't know. So if it's NIH dollars, it costs money to donate. So if we have a US institution that needs help, because not everyone is very organized with their data because IT is expensive, we can help pay and put money out. If we have a foreign institution who wants to donate, they can definitely donate. We just can't give them NIH dollars. So if we get non-NIH dollars, we could help them. So I think the same thing probably applies right now. I think it's only a US thing, but it's a model system to look at.
Let me just ask a specialized question that's been rolling in my head. We want to develop AI tools, and potentially these could go forward some type of regulatory approval, whatever it is. And in order to ensure the integrity of that process, the data sets that were used to train and then validate that tool are theoretically saved in some way, shape, or form, so that they can, be looked at downstream for evolution and improvement or comparability or whatever. Who does that? What, ATCC has these kinds of things that they create repositories that lock into cellular reagents and stuff like that through time. Is there a service that's coming out of Midrick that's going to be a place where you can reposit all those kinds of information around, useful tools that we want to, kind of understand the provenance?
I mean, a tool that's developed by a AI investigator? Yes. So we have resources, tools that we develop that we put on our GitHub. And if an investigator has something and wants to share it, we can have it shared. Just like we have our own annotations, we have third-party annotations. We note where they come from, but same with the software, they could be put on our public GitHub if they want to share it. I want to point out that the winners of our challenges, if they want their prize money, they have to post their algorithm on our public GitHub.
Don't say the data sets.
That's what Midrick's all about, is data sets.
But do they have a vault for, historically,
Well, we hope we'll be around forever. So yes, it is like you put it in there, but we have our main pot, which is the 80% that is open and all. And then we have collections. So if someone says, I have because we're listed, just like IDC, we're listed on when someone submits an NIH grant, they have to say, I'm going to share my data. And Midrick is one of the choices they can check off to share it with. I don't know if that was where your question was going.
I have a related question, actually. Sean Payne from the University of Iowa.
How, with all this de-identification that's going on, is there some kind of tracking number that's common to a given image? Because there could be redundancy, right, in a lot of these publicly available data sets.
Generally, we deal with that just hashing the pixel data. So, the pixel data itself isn't identified. And so unless you've done something to the pixel data, which by nature degrades it, the pixel data here and the pixel data there, if it's a copy of the same thing, your hash comparison should detect that. You don't want to depend on the metadata because chances are the images will be detached from the metadata at some point in the process. And furthermore, if you did, then it would be sort of like a unique identifying attribute in its own right, which you normally remove during de-identification.
So is the burden on the person training to make sure that they're not training on the same data over and over?
That's a fairly routine thing in AI. Tell me if I'm wrong, people who do this, but normally you would be fairly cognizant of that risk, shall we say.
And that was one of the big problems at the beginning of COVID, because people were everyone doing AI wanted to do it AI for COVID, even if it wasn't that clinically of a good question for some of them. But everyone was looking for images, and maybe 2 data lakes had the same patient. And that's why stuff was had performance that was higher than it really was. Other people were drawing images from papers. They were downloading them. They were so desperate. So there was a lot of messy AI work during that.
Thank you.
I just wanted to make a point and then ask a question. First of all, a point on patient consent. I think this is something that is getting traction predominantly in the private sector. And I think it's worth looking at some of those examples. One of the largest imaging chains in Europe, I won't mention the name at the moment, but they operate in 15 different countries. In many of their countries now, they are running an opt-out scheme for their patients to be able to use their imaging.
Mhm.
I work for the largest outpatient imaging provider here in the U.S. with RadNet DeepHealth. And we're in the process of implementing those same kind of systems. And those are organizations too that are very patient friendly, have a lot of patient engagement tools to be able to do this. So I would just challenge everyone to say, again, it's not about the lawyers, it's about the incentives and really finding those patients are willing, if you educate them, to really sign up. And if you go to this provider in Europe, they're seeing the majority of their patients are really not resisting, and they're being educated about the process, particularly with AI being a part of that. So that's just a point I wanted to make. But the question I wanted to ask the panel too, and again, I think it's having prior to joining RadNet, I worked for a large cloud provider, and I spent the last 4 years, even during COVID, setting up very large data sets in the cloud for the purposes of getting all of the data that we needed to be able to address the pandemic. And it's interesting to go to multiple different conferences now and feels like we're having the same pre-COVID conversations around data sharing. And that's the other term too, I think, that's important in this community. And as we communicate it out, that we don't talk about data sharing at my previous employer, we were never allowed to use that term. We talk about data access because that's really how it's enabled. I've set up multinational clinical trials for the early detection of pancreatic cancer using genomic data, clinical data, imaging data that is being hosted locally in a cloud in multiple different countries around the world. And data scientists and researchers are accessing that. The UK Biobank is another example that is providing access to their data sets, and it's very open. You go in and sign up and you can have access to a treasure trove of data. And so I guess my challenge and my question to this group is, seeing what BCSE does here in the US, which is still siloing all of their data in their different regions. Again, the academics sort of hoarding that in their different regions. I'm thinking about other cancer registries. I've worked to download 15 years worth of breast cancer data for a single country that's sitting in the cloud, but not being leveraged on a global scale. And so I guess with the technology there, with data access being the operative term, how is this group thinking about what it is that it can do? And second of all, how can it do it with industry? Because all of these initiatives that I have seen being successful really required industry to come to the table and importantly, help drive that standardization conversation, because I think industry is very good at helping standardize the metadata that needs to be there. So just something I'd love you to respond to.
Well, Rick has already started talking about some of the tools. You want to go into
The history of open databases is mostly quite depressing. Almost every single one has been shut down. If you go back through NCI history, if you go back through many others, I think the UK Biobank is one of the more exciting examples. That how many cases was that? That was huge, right?
500,000.
500,000 cases, but unfortunately, they didn't include as much imaging, right? It was
That's in the process. It's being uploaded.
Yeah. For our community, we tend to capture longitudinal data with a lot of structured reporting metadata. One thing we did do as part of I-ELCAP was we took the I-ELCAP data dictionary and we made it publicly available. So now many other sites, many other companies and other entities are following that data dictionary. And that's a step in the right direction, but probably not as far as you'd like to see it go, right?
Well, there's also, lots of publications around the fact that the data donations that we would like to envision most probably or oftentimes are from communities that are vulnerable in some way, shape, or form. And that their willingness to participate in these things is an issue of trust that we haven't really seemed to have fully met. And, there's instances where large corporations are delighted to have images, but the value proposition for the individuals donating that image is not as well developed. And I think that mismatch has to be addressed. And I know there's efforts to do that. NIH has done some of them, but it's still overwhelmingly a challenge as we try to develop these equitable, sophisticated imaging AI tools to ensure that it has, diversity in the tools that are developing it and then validating it. Mary Ellen?
I just wanted to add to what Rick was saying, and it is a shame that there are a lot of these funded data repositories that come and go. And been a big topic with Midrick from the very beginning. How do we sustain so Midrick keeps growing and stays around? And that's how we're using the sequester database. Because right now we're doing a few companies for free, so we can work out the process of how do we go through FDA. We're going to do a few mock FDA submissions, but ultimately we'll have industry we're hoping that it's less expensive and more efficient, because we've taken companies through the FDA process where you have to go find the cases that span the normal, span the abnormal. It's an independent test set, use that and go through FDA. Hopefully companies will instead come to Midrick. Either, we haven't decided yet whether the companies will pay a membership fee or a pay per test for the help them to go through FDA, also give them advice on how to go through FDA. But sustainability model has been on our top of our list from day one. And we talk with NIBIB about this and others a lot. And I think that's what a lot of data commons might not have had, because it is great data out there that just puts on a.
Yes, sustainability is crucial. And we took a completely different approach to Midrick in IDC because we are constructed from a different perspective. Our primary goal was to not so much share data as enable cloud computing on data. And it happened to be shared. And many of our sources are data that were publicly shared already, but shared in a proprietary infrastructure on site, which could vanish tomorrow if the funding was to cease to exist. So we were fortunate enough to engage first Google and then Amazon in supporting the public data set initiative. So as you know, I'm sure everybody in the room knows, Google and Amazon, and I dare say Azure probably somewhere too, have public data sets that they see as for the common good that they pay for. They pay to store it, they pay to back it up, and they pay for the egress and the ingress. So it's essentially they pay for everything. Now, why they do this? No idea, but they do. So we took the approach that we would leverage the Google infrastructure to start with, and then the Amazon infrastructure. So all of the IDC data, which some comes from TTIA, some comes from other sources, as in these public buckets. So they're on Amazon, they're on Google, and when IDC goes away, which it inevitably will, either the people running it will get bored, or the funders will get bored, or whatever. Google and Amazon will probably outlast the US government, so we're probably fairly safe in saving the data there.
It's a bad quarter, and
it may go away. That's why we have redundancy. So we have the same data, for example, in TCIA, Google, Amazon, and probably thousands of other places around the world who maintain their own copies of the collections for their own. Like I have every single head collection because defacing is now an issue. So I maintain my own personal repository because I know that this data may go away someday and I won't be able to do research on it anymore. So I have a repository should anybody need it. And there are many other like this, but sustainability is absolutely critical, and you can't depend on your funding source or your business source, obviously, which is why I think replication is the answer to sustainability.
But we also have a particular problem because what we're doing is developing early detection tools that are going to be applied in a public health context. And by definition, we want to keep costs as low as possible. And we've seen a lot of initiatives around areas of imaging where there's a higher value proposition from a commercial, but the public health kind of effort is a real challenge. One of the things that we've adopted, and this is more conceptual than real, but it is coming forward, is that we have all these databases and everybody's looking at them with different tools and this, that, and the other thing. So one possibility is to create some reference tools that are available across the community so that at least you have common analysis tools so that communication about characteristics and evolution can be facilitated. Now, David, you're Ian Kelowitz, you're involved in these efforts. Kyle as well. Is that a strategy that people feel has resonance in terms of allowing at least some commonality to advance interaction so that collaboration is more fluid and feasible? Did you want to comment on that?
Oh, I totally agree. I just thumbs up. Having worked globally with multiple different data registries. Yeah, as I was saying, I've worked globally with data registries and setting up clinical trials, and the amount of time and effort that goes into just getting that standardization, that's the biggest, as many of you researchers know, if you're trying to do something like that, that's the biggest cost and the time consumer. And industry now too, and I'm speaking about pharma in particular, when they come and want to do it, they want and the term is now that certainly at RadNet, that's what we use. They come to us and want industry ready data. They don't want us to want to come in and say, okay, over the next 2 years, can you curate this set for us? They want things ready in a longitudinal fashion too, but they want that lexicon to be standardized to other parts of the world now too, because as we're moving into the Gen AI and large language model world, the data sets do need to be larger and they need to be more representative. As you
Yes,
pointed
yes.
out. So I was saying, I think it's a great suggestion if we could, and I think, you know, the breast cancer community did that pretty well. I think there's still some differences, obviously, because of the way screening is done and the way patients are managed. But I think this community is kind of at the start of that journey and could really standardize that
Okay.
well.
Thank you. Thank you. Kyle, did you want to comment about the potential utility of qualifications and MDDT type things from the FDA perspective in terms of, you know, populating a more robust data set, tool set?
One of the things that we talked about yesterday was open source software. So I think people heard the case I was trying to make for that, but the MDDT program is quite a bit broader than that. And there are a number of entities that are looking into the potential for qualification of imaging phantoms for calibrating imaging systems, and especially for data sets. And wouldn't it be lovely to have data sets that had FDA's sort of seal of approval saying, if you use this data set for this context of use, that the regulatory process for reviewing an algorithm would be accelerated, because we've already considered and said yes to that being a paradigm for evaluating those kinds of products. So companies would know that they've used a data set that really reduces the number of FDA questions.
Is there any comments? David? Let me finish up with David, and I'll come right to you, Matthias. David, did you want to say anything about any of this? If I insist.
You know, in lung cancer screening, at least since this is the topic, I mean, back since we started, this was Claudia's vision, was to create a data set. So reports all had to be on structured data forms. Everything had to be annotated at that time as best as possible. So we have collected that kind of a database for 30 years, roughly. So yeah, so now we're just trying to figure out after all of the effort in creating it, and we're trying to utilize it now with this AIRS project for primary read, because we think this data set is probably or reasonably unique now. I mean, eventually others will catch up, but this is longitudinal data. Yeah, I think we're trying to figure out now how to best use it for, as they say, the greater good.
So the problem is sustainability. We haven't figured that out.
Just give it to Google.
We've managed so far. We've managed so far.
Matthias?
No.
Why not? It'll be sustainable. It's like ImageNet. I mean, ImageNet changed the world.
No differences. Amazon.
No, they're all the same. I mean, it's just, they're evil, but they're useful.
But you don't rely on them. You don't rely on them because you keep your own.
Use your microphone, please.
Well, I don't trust anybody, as you saw from my slides. So I keep a copy of everything myself, but you know, I'm a rich white guy, so I can afford to do that. But most people can't. You know, you can hoard your own data and you can fantasize about its future utility, or you can share it. Sorry, he's fine.
You make it more and more and more
I'm
difficult.
just being provocative, but, you know.
You made Alker speechless.
Okay, what about when someone breaches Google or Amazon or whatever? You just say it's redundant, so we don't care.
Well, I mean, you know, those guys have large teams focused on data security. And when they have breaches or incipient breaches, they immediately react and respond no matter what time of day it is. And they're relatively effective at it. That's very difficult to support with your own in-house IT team. And so the service level agreement, if you want, with your security team, it's challenging to meet these concerns. Of course, if it's publicly shared data, you're not concerned unless there's a PHI leakage in it, in which case you want to try and withdraw certain components of it from availability. But for sequestered data, you obviously need a extremely robust security infrastructure. And you know, most healthcare institutions are currently facing the incipient threat of a ransomware attack, for example. Change Healthcare just crippled, you know, an entire subsection of the medical industry in the United States because of some defect that wasn't really their fault, but it was some third-party provider that they were dependent on. You know, so even someone as large as Change Healthcare can't deal with these issues. So, if you're going to do security, you've got to leave it to the professionals, is my argument.
Yeah. I will point out that
Okay, what sequence here? On this topic, who's going to talk on this topic? David's last comment. Okay.
But I totally agree with my neighbor. So about talking about data breaches and cloud and on-premise. So just check the latest Verizon report, which I did last week. So 69% breaches is on-premise. So only 30% is in the cloud. And nevertheless, 95% is human error. That's for sure. So for me, it's not a question which is more safe. For sure, it's the cloud environment because they are more specialized in holding data and also securing the data.
Okay. 1, 2, 3.
Okay.
1.
From academic institutions now, data is the new currency. And every academic institution has a tech transfer office. You try to say, we're going to give away this data because it's a good thing. They are just trying to figure out how you shouldn't be giving it away. Have you run into this?
Oh, yeah, absolutely. I mean, there are many competing
looking at me.
viewpoints. And there's
But I wanted this answer.
there's no way around that. I mean, it's a balance.
But we have done it. We have multiple institutions. We have data, people in the pipeline, data coming from 23 states. right now.
I believe you, but
And
I'm
they-
saying, I've seen several institutions now, they just view the data as their currency. How can I make money off of this? This is what the institutions are thinking.
Well, there's a lot of data. So some of it you can monetize, shall we say,
Yeah.
and some of it you can share. And it's just like, you know, Mary Ellen wants to sequester 20%. Fine. That means it's 80% available for everybody else.
Yeah,
That's a reasonable balance.
that sophistication has not occurred in most tech transfer offices.
I think E-ELCAP was the right model. It was keeping the data in the region that it was collected with cloud, in the cloud, okay? And you can pick whatever cloud provider you want. And the ultimate, I think one of the ideas, E-ELCAP never got there, but one of the ideas was make it so that the sites actually get some value when people run their algorithm against the data. And once we create a system where everybody basically gets something for being part of the system, it'll self-sustain, but we're not there yet.
Okay.
Right.
Matthias, your comment?
Yeah, you were talking about an army. So
That's right.
you were talking about an army of professionals securing the data, the Amazon, the professional clouds. So that raises in my mind also that there could be a major attack on Amazon and Google. And though the major threats will be in those clouds. So is that a reason why you should be more secure with very valuable data to put them not in those clouds?
I don't think that really makes sense. In that, for example, I do a lot of Amazon shopping. I get same day delivery. I mean, you guys in Manhattan, you'd probably get same time of day delivery. It arrives before lunchtime. And all of my credit card information is there, and Amazon knows more about me and my personality and my preferences than anything else. So I'm much more concerned about my Amazon personal information than I am about my Amazon healthcare data or my images, which are really not very much risk to anybody, sitting in the cloud. So, I think we have to keep this in perspective. What is the relative value of the data? Is the data valuable to an AI competitor of the person who owns data? Maybe it is, but there are easier ways to get it probably. I think that healthcare data just isn't as valuable as credit card data, for argument's sake. Amazon knows how to protect credit card data. The cloud infrastructure pieces are sort of part of a foundation upon which everything else is built. So obviously the amount of diligence applied is different in the Amazon store than it is in the public Amazon cloud. But these are all contractual matters.
Okay.
Service level agreement, insurance.
Okay.
That's the ultimate. You just insure yourself against loss.
Got it, David. Thank you.
Sorry.
Your point is very well taken. Mary Ellen.
Yes, so one, I will agree. People are going to be more after the credit cards than your chest X-ray. So also what I wanted to tell you is that Midrick is in the cloud. With tools from multiple, AWS and Google that people can use it. And I think making it a mixture of centralized with distributed sites. Some people, they want to keep their data local. One can do that. But I also want to point out there's a slight difference in philosophy of Midrick from other repositories. A lot of other repositories, if there was a clinical trial, they took the clinical trial data and put it there. Someone did a in-house study, they put the data there, and they're kind of by groups of data. What we do is we go to, say, a hospital and we take in, say, 10,000 patients' data. And then we go to another one and do the same. And then we leave it to the front end of Midrick for people to slice and dice it. So when they do their AI study, they might end up with cases a little bit from this institution, and that institution. So it's more of a pot of images, slicing and dicing at the user end as opposed to specialized ones.
Can I say one more thing about the cloud before we finish? And that's that the data has to be on the cloud to do practical research on it in future, simply because the cost of computation is so low. We ran 21,000 virtual machines simultaneously on the NLST data to segment the whole body using total segmentator. Took about a week, cost us $800. So, you don't need your in-house high performance computing. The data has to be on the cloud, and it has to be on the common cloud providers. And there has to be zero egress charge between the storage and the compute to make these kind of things feasible. So there is no choice but putting it in the cloud.
NIH has had a series of publications from various of its computational leaders on this point, and it's orders of magnitude difference.
Yeah, huge.
No problem.
Wait a second. The cloud is not the least expensive thing to do. You can set up your own server and you can hold it there for less money. And the problem you have is that eventually it's going to end of life, and Amazon's going to
Like in a week. As soon as you buy an NVIDIA chip, it's obsolete.
Well,
There's a new one
it's
next
still
to it.
useful for a few years. But my point is that a lot of models I see that are preferred are hybrid, where you give the customer the opportunity either to store it locally on their own computing services or utilize the cloud. I think that's probably the way to go.
Yeah, but the processes you set up with Amazon, no, it was Amazon, to flex for the analysis and stuff like that, it'd be very, very hard to do in another environment.
It's true. What we did with I-ELCAP was we kept a very small EC2, what's called an EC2 instance running, and it cost almost nothing to keep. I mean, it cost very little to keep it running. And then
it costs something though, Karen.
Now, to be honest, it cost around $100 per month to run on, it's just mainly storage. If you just keep data on Amazon, it costs money to do that. But then as soon as we got a big AI job, we would launch additional EC2 instances some of which are massive, which there's no way you'd pay for
Hmm.
individually. And we'd run them for, you know, a half an hour or something like that. So it is definitely the most flexible and the way to go generally. But there's lots of regulations globally. And
Yes.
oftentimes you want to respect that and let the site decide. Of course, that we also have to keep in mind the algorithms when you ship them out to sites to run, those have to be secure as well. So in addition, if you can't, you can't just go send an algorithm to a site with a local administrator who you don't even know and expect security around that. So there's a lot of considerations, but it can all be done. It's not that hard.
Okay, we're at time. We have a interesting question from Gudrun Zalman, our colleague, who we'll have to deal with offline. But I wanted to, and with Tony, thank all the panelists and all the interaction we had from the participants. These are critical issues. It turns out nothing's easy, but we have a way forward. It's kind of awkward, but we have some real opportunities. And so thank you very much for sharing your knowledge with us.